All right, part 3 of what I foolishly thought would be a single video. What I want to do in this video is transform graphs of sine and cosine with both horizontal and vertical transformations. And what I'm going to try to do is make this as similar to a quiz as possible. What I would give you if this was a quiz is I would start you out with blank axes like this, and they'd all be scaled for you really nicely. And what I would ask you to do is sketch some graph, but it wouldn't be a one-step process. I'd first ask you about the amplitude, then the midline, then the period, then the phase shift. And then after doing all of that, then I'd have you sketch the graph. So if you were doing this problem, what you'd want to be able to do is look at this equation and immediately figure out that playing the role of A is a 3, playing the role of B is 1/2, playing the role of C is negative pi over 2, and playing the role of D is negative 1. And that's because A, B, C, and D were defined to be the numbers in those 4 places respectively. And note I wrote them in kind of a weird order. I wrote A and D next to each other and B and C next to each other because A and D are your 2 vertical transformations, so they kind of go together in some sense, and B and C are 2 horizontal transformations. It'd be nice if you knew that the amplitude was always just the absolute value of A. So in this case, your amplitude would just be equal to 3. The midline is always given by the equation y equals d. So in this case, it would be y equals negative 1. And I'm not going to mark you off if you don't write y equals. If you just say my midline's at negative 1, I know what you mean, and that's good enough. The period is always going to be 2 pi divided by the absolute value of b. And if you leave off the absolute value, that's not a big deal because I'm always going to give you positive values of b. So in this case, it would be 2 pi divided by 1/2. And as we saw in the previous video, when you divide these two numbers, you get 4 pi. And the phase shift is always negative c divided by b. So in this case, c is negative pi over 2. But actually, I want it to be positive pi over 2, so I'm going to change this. We'll make this positive, and we'll make this positive. And now my c is the negative of this positive number. So it's negative pi over 2 divided by b, which is still 1/2. And when you divide these two numbers, you get negative pi. And so if this is a 10-point problem, maybe you get half the credit just for writing down these 4 numbers right here. But the other half is being able to use those 4 numbers to sketch the graph. So how do you do it? I think it's easiest to start with the midline. The midline is at negative 1. So what I like to do is sketch a line that has a height of negative 1, maybe a dotted line or something. And from that midline, your amplitude is 3. So what that means is from this midline, I want to go up 3 units, 1, 2, 3, and sketch another dotted line. This is not actually part of your graph. It's just a guideline to help you sketch it. From this midline at negative 1, I also want to go down 3, 1, 2, 3, and make my last dotted line. I now have the bounds in the vertical direction of my graph. All I have to do is worry about what about in the horizontal direction. Well, the phase shift always gives me the x coordinate of what I refer to as the starting point. So that negative pi is telling me I want to start my graph at an x value of negative pi. If you want, you could sketch another line here that's vertical, although you don't have to. I usually leave this off, but in case it helps anybody, I'm going to put it in. And then consider your period. The period starts at this negative pi, and it says it's taking a distance of 4 pi in order for this to do 1 full revolution. So from negative pi, 1 pi, 2 pi, 3 pi, 4 pi, it looks like it should do 1 full revolution by the time I get out here to 3 pi. Again, I usually don't draw this vertical line, but in case it helps you, I wanted to draw it. We now have all the bounds that we need to sketch our graph. Note that this is a sine graph, so what that tells me is that I want to start on the midline. So I'll come all the way out here to an x value of negative pi, and I'll put a dot right here on the midline. And I remember that my sine graph not only starts on the midline, but also ends on the midline, so I'll put another dot over here. And one other thing I might remember about my sine graph is it goes up and then gets back to the midline when it's halfway through. So halfway between negative pi and 3 pi is here at 1 pi. I have 3 points on the midline. Between the first 2 points, I want to achieve a maximum. So up here at this dotted line. And between the second 2 points on the midline, I want to achieve a minimum. So I get my dot down here. Connect these dots and you have the graph of 3 times the sine of 1/2 x plus pi over 2 minus 1. To test if that made sense, let's do another one. Suppose you were asked to sketch the graph of negative 3 cosine of 1/2 x plus pi over 2 minus 1. What we're going to get is almost the same values of a, b, c, and d. The only difference is now a will be negative 3. B is still 1/2, c is still pi over 2, and d is still negative 1. Because the amplitude is the absolute value of a, my amplitude will be the absolute value of this negative 3, but the absolute value of negative 3 is just positive 3, so I'm going to have the same amplitude for my graph in red that I had in blue. My midline is given by the equation y equals d, and because d is unchanged, my midline is still at y equals negative 1. Because b and c are the same values in red as they were in blue up here, My period and my phase shift will be unchanged. Those will still be 4 pi and negative pi. In fact, for this graph, amplitude, midline, period, and phase shift are all going to be the same. So if I were sketching these guidelines, they'd all be in the exact same spot. So what changes? Cosine instead of sine and negative instead of positive. The fact that it's cosine tells me I don't want to start at the midline here. You're like, oh, right, cosine starts out at the top, right? Normally, yes, but because I have this negative here, it's going to flip my orientation. So what that means are all the maximums are going to switch to minimums, so my starting point will be down here. Normally, cosine starts out at a maximum and finishes at a maximum, but because I'm switching maximums and minimums, this negative is flipping the orientation. I'm going to start at a minimum and end at a minimum. Halfway in between those two should be a maximum, so it's going to go through this point, and halfway in between those points, I should be back on my midline. What I'm saying is I get these 5 points, which should be enough for me to sketch the graph of -3 cosine of 1/2 x plus pi over 2 minus 1. Let's run through one more example to really make sure that this is all making sense. Suppose you were asked to sketch this graph. What I'd want you to do first is recognize A, B, C, and D. A is -2, B is positive pi, C is -2 pi, and D is positive 3. And that comes from this constant, this constant, this constant, and this constant. From those 4 things, we can figure out amplitude, midline, period, and phase shift. The amplitude is always just the absolute value of A. So the amplitude in this case would just be 2, the absolute value of -2. The midline comes from the equation y equals d. Because d is 3, my midline is at y equals 3. The period is always 2 pi divided by the absolute value of b. In this case, b is pi. The absolute value of pi is just pi. So I get 2 pi over pi, which is just 2. And the phase shift is always negative c over b. C is -2 pi. So I get the negative of -2 pi, in other words, positive 2 pi, divided by b, which is pi. I get 2 pi over pi, which is also 2. As I set up my axes here, you might notice that the x-axis is no longer scaled in terms of pi. The reason the x-axis isn't scaled in terms of pi anymore is my period and my phase shift don't involve pi. Because there was a pi in place of b, I kind of divided out those pi's. What that means is the amount of time it'll take in the x direction for this thing to repeat is no longer 2 pi, it's just the number 2. And the x coordinate that I'm going to start my graph at isn't like, I don't know, pi over 2 or 3 pi or something. It's just at the number 2. So I want to scale my x-axis in terms of ones, not in terms of pi's. I start out by locating my midline at 3. There's that dotted line. From that midline at 3, I want to go up and down by my amplitude, which is 2. So 3 plus 2 more gets me up to this 5 here. And 3 minus 2 gets me down to 1 here. I now have my guidelines in the vertical direction. What about horizontal? Where do I want to start this thing? Well, my phase shift is 2. So what that means is my starting spot in the horizontal direction would be here at 2. Often people leave off these vertical lines, but in case it helps you, I want to draw them. And then from this 2, it's a distance of 2 to the right. The period is 2. It's going to take me 2 for this thing to repeat. I want to start at this 2 and go 2 to the right and create this line at 4. That kind of creates this little box, and inside this box will be one full revolution of my graph. Yeah, but what should I graph? Well, because this is a transformation of sine, I'm going to start out on the midline here. And because there's a negative here, my orientation is going to be flipped. So I'm going to start out on the midline. I'm going to end up on the midline because that's what sine does. And halfway between the start and the end, I'm going to be on my midline, as sine always is. Typically, the normal orientation for sine is for it to start out by going up. But because of this negative, I flip my orientation. So it's going to start out going down. Halfway in between these 2 dots, I want to reach a minimum. Halfway in between these 2 dots, I want to reach a maximum. These 5 dots are sufficient for me to sketch a graph of this transformed function. This graph continues infinitely far in both directions, but I'm just going to draw one full revolution because I think that might help you see what's going on. If you could follow this example, that's pretty impressive because this is a pretty challenging section. And if you can follow this example and the ones in this video, I think you could sketch any transformed sine or cosine graph. What we'll see is that almost finishes the section. The only thing left to do is to go in reverse. What if I started you out with this graph? Could you come up with this equation? And it's not as daunting as it may seem. We'll use the same techniques, but that's something I want to save for the next video.